Hey, Algebra 2. Sorry for the late post. Hopefully this gets to you in time. Things got a little hectic. That's okay. But this will be on YouTube. I may or may not have timestamps so that you could skip around. But remember, it's a YouTube video. If you're comfortable with this or you're understanding it, watch it on fast forward. You don't have to sit here and watch the whole thing at a normal speed. That's what videos are for. Okay. So, taking a look at the notes. So, the steps 1 through 4, this flowchart's a little wordy. So, I'm going to break it down baby steps. So, step 1. Okay, so we have these three equations here. We have 2x minus y plus 3z equals 9, 4x plus 2y minus 2z equals 10, we have x minus y minus z equals -5, okay? So the first step, and it says, choose two equations. So that's what I did. I looked from these three equations in my systems of equations. I found two of them that I think I could eliminate one variable. So in this case, looking at the blue and the green, so this first equation and this third equation, it looks like y is going to be pretty easy to eliminate. And yeah, that's true. If I take 2x minus y plus 3z equals 9, and I multiply the third equation, the green one, by -1, then when I put them together, the y's are going to cancel. Yes, the y's will cancel. And we're left with x plus 4z equals 14. Okay, so that's step 1, is we want to eliminate one variable and using elimination to get that. So we picked two out of these three equations and eliminated a variable. In this case, we eliminated y. Step 2, since we eliminated y in step 1, then step 2, we need to eliminate y again. So we need to make sure that we end up with two different equations. So we ended up with one here, and we're going to end up with one here. We end up with two different equations where we've eliminated y. So step 2 is we used the blue and the green equation, right? We used the first and the third equation. In step 2, we need to use two different equations. So we're using the red and the green equation this time. So that's going to be the second and the third equation. So once we use elimination to solve this out, hopefully at this point you feel pretty comfortable with elimination, we end up with 6x minus 4z equals 0. So in both of these equations that I've highlighted in purple, I have two equations, two different ones, where I don't have y. All I have is x and z. So that's perfect. So I take these two equations, and I'm going to stick them right up here. So I have x plus 4z equals 14, and I have 6x minus 4z equals 0. I take both of these equations I got that don't have y's, and now I just have a system of two equations with two variables, and we know how to do that. In this case, I think eliminations are best bet because positive 4z and minus 4z will cancel. We don't even have to do anything. So we're left with 7x equals 14, divide both sides by 7, and we're left with x equals 2. So perfect, we found our first variable. The next step we need to do is find the second variable. So the easiest way to do that, we've already solved these two equations that we know are true, and they're in terms of x and z. So if I take this x value that we found, x equals 2, and plug it back in, we'll get z equals 3. So it looks like I plugged x equals 2 into the top equation here. X is 2. So 2 plus 4z equals 14. So now I have two variables. I have x equals 2 and I have z equals 3. Once I have those two variables, then all those original equations that I had at the beginning, if I plug in x and z now, so the third equation looks like the easiest one to do that. If I plug in x and if I plug in z, all that's left is going to be y. So if I do that, take that green equation, plug in 2 and plug in 3, I end up with y equals 4. Okay, so that's step 1 through 4. And we didn't always go through this exact flow chart. And there are cases where it's easier just to do what we did in class, was just add all these equations together to eliminate a variable. That's possible, in this case. And that's not always true. So I think it's good that I show you steps 1 through 4, because no matter if your systems of 3 equations are easy or if they're really difficult, steps 1 through 4 will always work. You might be able to do it faster doing it a different way, but sometimes it won't always work. So we can always rely on this 4-step process.